Hello everyone, I'm Oshura. Today we are discussing about class 11 physics chapter number 4 motion in a plane. So in this lecture we will discussing about that the unit vector. After that last we were discussing about unit vector, and then after we will discussing. So let's start from the unit vector. First of all, unit vectors. In the previous lectures we have lots of things are shown. What is see here vectors in a plane, vector addition, velocity vector additions. Okay, vector, what is a vector, what is a scalar, we all know the graphical addition of vector, and after also vector simulations. Now see here types of vectors, displacement vectors, also the parallel vectors, anti-parallel vectors, relative displacement vectors. All those things are we have known about that. And after also we main things are one of our important things of that vector addition via parallelograms. So we have also discussed in this previous lectures graphical method of vector additions, graphical subtraction of vector additions, and also vector component how it comes. And after vector components, graphical method of vector additions, then we will discussing about the unit vector in a rectangular coordinate systems. So see here there are the three dimensions are there, I, J and K. So it's represent with respect to x with respect to I, y respect to j cap, and z respect to it is known as the k cap. So it is a respect, there are the x with the I directions are there, y with the z directions, and z with the k direction. So there are the three different directions are there, I, z and k. So I cap, j cap and k cap. I cap, J cap and K cap. This is known as the cap. This phenomena is known as the cap. So I cap, J cap and also K cap. If it is a value is one, only one value, so on that time we will see is that the unit vectors. Okay, this vector is known as the unit vector. So I first of all, if suppose I has a value is 1, on that time it is known as the I cap, it is a unit vector, j cap it is unit vector, also k cap it is a unit vectors are there. So this is our unit vector in a rectangular coordinate systems. Now see in the three dimension, this is our one only just as simple as a unit vector direct. But see whenever we are discussing about that the unit vector, see here this is our box is that, okay, and our vector is a, see here our vector is a. So with respect to there are the, it is a parallelogram directions are there. Okay, see here it is a parallelogram direction, it is not situated at here, it is not situated at here, but it is a situated at a in three directions. So this is x, this is our x, our y, and this is our z. So there are the three directions and it is situated at here. So see here our a it is our vectors are there. So if the ay it is a with respect to it, our ay vector is ay into j cap, in direction of x it is ax into I cap, and in direction of k it is az into k caps are there. So it is represented as the a vector it is represented as ax I cap plus ay j cap plus az a cap. So if our vectors with rectangular unit vectors, it is represented as a vectors and it is equals to ax I cap plus ay j cap plus az k caps are there. Also suppose we have considered as a b vectors. Okay, here we have considered as a b vector. On that time what we will do, we will doing that the b vectors are there, then bx I cap, by j cap and bz k caps are there. So see here, if we are discussing about the b vector, on that time we can say bx I cap plus by j cap, and also it is represented as the bz k cap. So it means there are the if our in three directions are there, on that time what we need to do, we need to do addition of all those vectors are there. So it is a basic things are there. So see here our a. Now see here, the dot products are there. The dot products for a scalar quantities. Okay, so dot product multiply the portion of A that is parallel to B with the B. So we will get that. See here, I dot I it is equals to 1. I dot j is equals to 0, and also I dot k is equals to 0. So see here, the other we see here we are I am making a one table for you only for you. So you can see here there are the I multiplied by I. See here if there are the I multiply by I, this is our dot products are there, it is a 1 values of 1. Suppose it is a multiply j with the I, it is equals to 0, and also whenever we are dot product with the j I multiply k, it is equals also 0. So see here the now so j, see here there are the j multiply I cap, it is equals to 0, and also whenever the j dot j, it is equals to 1, and again j dot k, it is equals to 0. So this is our dot products. It means in the dot product there are the I dot I cap is equals to 1. It means that also j dot j is equals to 1, and also k dot k it is equals to 1. So this is our dot product of the scalar quantities are there. Now we will see here dot product of a scalar quantity in a two dimensions are there. On that time what will happen, a dot b is equals to ab cos theta. Okay, it is a ab cos theta. Now in any numbers of dimensions, when in any numbers of dimension, it means there are the n numbers of dimensions, suppose. So on that time what will happen, a dot b, it is equals to a dot ax dot bx, it is plus ay dot by plus az dot bz. So the dot product multiply the portion of A that is parallel to B with the B. So it is our A dot A, B, A dot B, it is equals to AB cos theta, and in a number of dimensions, in the any number of dimensions, in the it is our two dimensions there, but in now in any numbers of dimensions, on that time what will happen, A dot B, it is equals to AX BX plus AY BI plus AZ dot AZBZ. So this is our dot product. Now see here we have shows that the cross product are of that. So when your what will happen, cross product, it means there are the different things are there. See here, this is our cross, this, see here, this is our cross symbols. So what is the difference between that? So whenever we are doing the dot product, it is a scalar quantities are there, and whenever we are doing the cross product, on the time what we'll get, what we will get vector quantities are there. So the cross product multiply the portion of A that is perpendicular to B with the B. So I cross I, it is equals to 0. It means the same direction has a value, cross product is equals to 0. But whenever we are multiplying with the another direction, on the time we will get that the another directions are there. Okay, so perpendicular of that time, it means there are the, see here there are the thumb, our thumb, forefinger and the index finger. On that time what will happen, the see when our thumb and the forefinger and the index finger making a 90 angle between them, and it will our thumb gives the directions of the resultant vectors of that. So resultant vector we will get that the directions of that. So see here, this is our cross product. So I cross I, it is equals to 0. So in this direction I cross I, it means that whenever we are talking about that the I cross I, it means that we are talking about the same direction. On that time what we will get, we will get that the zero values are that. And whenever we are discussing I z dot I j I dot j, it is equals to I dot I cross j, it is equals to get the value of k. And whenever the I dot I cross k, it is equals to minus j values are there. Then after also the j dot I, it is equals to j dot I, j dot I, it is equals to minus k, and j dot k, j cross k, it is equals to I cap. Also k cross I, it will be gives us k cross I, it will be give us j, and k cross j, it is equals to minus I values are there. So we will get that the 9 values of that the I, j and k cross I, j and k vectors. So we will get that the values of different values are there. Now see here a cross product vectors in a vector quantity in two dimension. On the time a cross b, it is equals to ab sine theta. Now see here in the any number of dimensions, on the time suppose see here your matrix are there I, j and k. On that time what we will get, ax ax ay az and bx by bz. There are the two vectors are there. So I, j and k, it is our directions are there. So see here ax into c, if we need to get the value of I, on that time what we need to do, ay into bz minus by into az. Okay, and now we get the value of j. On that time what we will do, my j plus is, see here here one mistakes are there, minus, it is our minus. Okay, so minus j. So on that time we are going to hide these things, j is hide these things, and we will get that the multiplication of ax into bz minus bx into az. So this is ax minus bz minus az bx. Okay, so see here, and also whenever we get to value of k cap, on that time what we need to do, ax into by minus bx into ay. So we will get that the value of I, j and k cap. Okay,